All right. So today we're going to do the third and final part of 7.2. On Friday, we talked about how to do the hypothesis testing with a p-value, which is what part 2 of your homework is going to look like. Today, we're going to talk about using rejection regions, or sometimes it's called a critical region, for hypothesis testing. A lot of this is going to be really similar to what we saw on Friday, so it's going to be a good set of review. When you guys are doing the homework, it might ask you for p-values, so that would be the method from Friday, or it might say critical values it's asking for, and that would be the method that we're going to use today with rejection regions. Rejection regions are what we're going to use more of in 7.3 also, so this is, I would say, between the two, probably the more common or popular method. All right, so a rejection region is pretty much going to be the regions in the tails when we're doing our tests. So if it's a left tail test, the rejection region is to the left of your z-value. If it's a right tail test, it's to the right of your z-value. And if it's a two-tail test, it's on either side. They're going to use a z sub 0 or a z null is going to be the critical value. So if you're asked to find a z sub 0, that's the critical value, or the z-score that's going to separate the rejection region from the region where we do not reject the null hypothesis. So guidelines that we're going to be using, we're going to find the level of significance on our own, or a lot of times you're going to be given that. Then you're going to figure out, or like review what we did before, left tail, right tail, or two-tail test, and then we're going to find the critical values. And we'll be able to find the area with those. If it's a left tail test, it's just going to be the area to the left, like we've practiced. If it's a right tail test, it's 1 minus our area. Okay. And then if it's a two-tail test, our z-scores are going to be half and 1 minus half. We're going to put those actually in a second on your Z chart, if you guys have that out, or if you don't, maybe grab it. The common alphas that you're going to use and the Z-scores that go with them are as follows. These are not on your chart. They will be for the T distribution, but they are not for the Z-score. So I would probably say, actually, I'll show you what mine looks like if I can find it. Put it on your Z chart somewhere towards the bottom. Let me see where mine is. So I just put it on like the positive side of my Z chart, just on the bottom here. I put what the alpha was, the level of significance. I put what kind of test it is, and then I put the Z value that's going to go along with that. So if you, it's the same thing you guys have up here. So if you just want to put that on your chart so everything's in one place, maybe it'll save you a little bit of time. Okay, so all of this in this little box on the left, it's helpful to have on your chart ready to go. And these are the 3 most common level of significances that we've talked about before, 0.1, 0.05, and 0.01. We want those low values there. So we have a less likely or low probability chance of getting that type 1 error. All right, so go ahead and get those on there just so you have them. Bless you. To the right of this, then, I'm going to show you how, if you have a level of significance that isn't one of these common ones, how you can find the critical values that are going to go with it. So let's say we have a level of significance of 0.03. Think of that as, if I draw this, if it's a left tail test, 0.03 is this area that you have to the left. So what we're going to do in our chart is we're going to work backwards like we did in the last chapter. You're going to find the area and then look at that row and column where the area is located, and that's going to be the critical Z value that you're finding. So 0.03, it's going to be a negative value because it's to the left, and you're just going to find the closest number on your chart to 0.03. And then you guys should see 0.0301 is as close as we can get. And the Z-score that corresponds to that is negative 1.88. Okay, so that would be the critical value that you're using for that hypothesis test if you have that level of significance. Now, if you have a two-tailed test, I'm going to draw this one. That 0.08 is located in both tails. So really in each tail you have half of that, 0.04. And so if you find 0.04 on your chart, that's the negative z-score, and then the opposite of that will be the positive z-score that you need. So 0.04, closest value I can find to that, I have a 0.0401 at z-value of negative 1.75. So my critical values for this one would be plus and minus 1.75. If you have a right tail test, just make sure whatever z-score you have is the positive z-score, not the negative z-score when you list it, because it's to the right of our mean. Okay? Good? Questions? Getting critical values. Okay. So, putting it together now. So we're going to be setting up our hypotheses. We're going to be looking at if it's left-tailed, right-tailed, or two-tailed. And then we're going to be finding this critical value z sub 0. And then we're going to have this region, and in this picture the regions are all shaded in blue, that we're looking for. If you have a z-score when you do your calculations with your data that is in the rejection region, you reject the null hypothesis. If your z-score is not in the rejection region, you do not reject the null hypothesis. Okay, and they're showing you the 3 different ways this can look, but pretty much if you're in the rejection region, you reject. If you're not in the rejection region, you don't reject, is the summary of this. All right, so practice with that. Here I have, looks like a two-tailed test. I have critical values at negative 1.96 and positive 1.96. Let's say you do your calculations with your data and you get negative 1.98. Positive 1.98. Is positive 1.98 in either of these blue regions? Yeah. Yes, it is. It would be to the right over here. So if it is in my rejection region, in that case, we would reject the null hypothesis. Okay. What about negative 1.89? Is negative 1.89 in the blue regions? Either one? No. It is not. Negative 1.89 is going to be like right there somewhere. So we would say we do not reject, or we fail to reject. What about 1.65? Is that in there? In the blue regions? Nope. It's below my upper z value there. It's going to be in there somewhere. So we do not reject. And then negative 1.99. Yep, that's in the lower rejection region, down there somewhere. So if I get a value like that, I would reject the null hypothesis. Okay? This is really similar to the p-values. With the p-values, we were finding the area and we were comparing it to the level of significance. So our final answer was really comparing areas. This final answer is just comparing the z-scores that go with those areas. So it doesn't matter what method you use, you're going to get the same result. I actually kind of like this one better because I don't have to figure out that area at the very end. I can just compare the two z-scores that I have. I feel like it's one less step, but both will work. All right, so let's kind of put it all together and try it. Same hypothesis test steps that we did in the last section. So we're going to start by finding all of our important information, all of our variables, write the null, write the alternative, determine the level of significance, and in this case we're going to be comparing critical values. We might even sketch that rejection region so we can see it when we compare. All right, employees at a construction and mining company claim that the mean salary of the company's mechanical engineers is less than that of one of its competitors, which is $88,200. A random sample of 20 of the company's mechanical engineers had a mean salary of $85,900. Assume the population standard deviation is 9,500 and the population is normally distributed. Level of significance 0.05. Let's test the company's claim. All right, so number one, can we use our standard normal distribution and hypothesis testing? Remember, the two things we want to talk about are, first of all, do we have a population standard deviation? Yes or no? Yes. We were given that. And then is my sample size bigger than 30, or is my data normally distributed?
Yeah.
Right, we're normally distributed here. Okay, so we meet all those check marks at the beginning that we can even do this. All right, so let's see. 88,200 is going to be the claim. So we're going to label that as population mean, which we're going to test, and we'll put it in our hypotheses in a minute here. Random sample size is my n. In this case, that's 20. And the mean of that sample, so x bar, is 85,900. Population standard deviation, my mu, is 9,500. Level of significance, 0.05, getting all those on there. Okay, let's write the null and the alternative, starting with the claim. All right, so the claim is that the mean salary of mechanical engineers is less than their competitors, which is 88,200. So mean is less than 88,200. Is that my null or my alternative? Alternative, because it does not have the statement of equality, which means the null is the complement of that, mean greater than or equal to 88,200. Okay, let's go ahead and find our z-score. So remember, formula for this was x bar, 85,900, minus my population mean value that's being tested here, 88,200, divided by my sample size, 20. Oh, I put that, hold on, sorry. Divided by my standard deviation, put that first, 9,500, over my sample size, we're at 20. There we go. All right, so let's type that in, see what we get. To 2 decimal places, negative 1.08. Good? Okay. Is this a left tail, right tail, or two-tailed test? It is left tail because my alternative hypothesis, remember that's the one you want to look at, is less than. My level of significance is 0.05, which is one of our common ones. So you guys can look at your chart now. You don't have to search for it. So we're going to look at level of significance 0.05. You're going to look for the critical value for a left tail test. And you guys should see that that is negative 1.645 is the critical value. Okay? Again, if it's not listed on here, you just search for that area and you work backwards to find the z-score. All right, so let's get a little picture of this. I have a left tail test. The rejection region starts at that critical value, negative 1.645. I have a z-score of negative 1.08 from our data, from this sample. Is that in the rejection region? It is not in the rejection region. Negative 1.08 would be to the right of negative 1.645. So if it is not in the rejection region, what do? Reject or not reject? We do not reject. So then our summary of this would be there is not enough evidence to, because my claim was the alternative, we're saying support the claim. And again, you can always get a little more wordy with that if you want to, that mechanical engineers make less than their competitors at 88,200. There is not enough evidence to support the claim. All right. Good. Let's try one more together, and then I'll let you guys do the third one on your own. A researcher claims that the mean annual cost of raising a child age 2 and under by married couple families in the U.S. is $14,050. In a random sample of married couple families in the U.S., the mean annual cost of raising a child 2 and under is $13,795. The sample consists of 500 children, assuming the population standard deviation is 2,875 at a level of significance of 0.1. Is there enough evidence to reject the claim? All right, so number one, do I know the population standard deviation? Yes. Is my sample size either bigger than 30 or normally distributed? Yes, sample size here is 500, so we're good. We can use our hypothesis testing with our standard normal table. All right, let's label things. Let's start with sample size, we said is 500. We have a mean from that sample, so X bar. 13,795. We have a population standard deviation of 2,875. And we have a mean that is part of our claim. So we're testing that as the population mean, 14,050. Okay, let's write the null and the alternative hypothesis starting with the claim. The claim is that the mean annual cost for raising a child is $14,050. So is that going to be the null or the alternative? It's going to be the null this time because it's going to have my statement of equality is 14,050, which means the alternative will be that it is not 14,050. All right, let's find the z-score for our sample mean. 13,795 minus population mean 14,050 divided by my standard deviation of the population over the square root of my sample size, 500. Round to 2 decimal places. I get negative 1.98. Okay. Is this a left tail, right tail, or two-tail test? This is going to be a two-tail test. So let's find our critical value. And when you have a critical value for a two-tail test, you're looking for the one on the positive side and the negative side. So we're looking for the critical values that have 5% above and below it, but this is a critical value that is, again, one of the common ones, so you should just be able to find it on your chart. So find that critical value of 0.1 that you wrote down, two-tail test, and you guys should see plus and minus 1.645 for the critical value of 0.1. Okay, so I'm going to sketch it. Sketch my rejection region, negative 1.645 and everything to the left, positive 1.645 and everything to the right. So now the question is our z-score negative 1.98 in a rejection region? It's going to be in that lower rejection region. Yes, it's below negative 1.645. So what does that mean? Reject or not reject? Reject. All right, and so then the summary of that, we would say there is enough evidence, and this time we use the word reject because the null hypothesis was the claim, to reject the claim that the mean annual cost of raising a child is $14,050. Okay. All right. Think you guys can try the last one? Yeah. All right, go for it. Ready to check it? Okay. a little bigger. All right, so reject the null.
Yeah.
Yes, double check all your numbers there. If I were grading this, I'd look at your claim, your null and your alternative, your Z, your critical value, maybe your sketch if they ask for it, and then these two pieces of information. Reject, and then how you summarize that fact that you rejected it. All right, what questions do you have on this process? Anything here? I'll leave that up there for a minute. Okay, so you have homework. There are 3 7-2 assignments, the mini ones. Hopefully you've been working through those as we do them. All 3 of those are due on Wednesday night. So you guys can take the next 20 minutes now, keep working on your assignments. Tomorrow and Wednesday, we're gonna do 7-3. Thursday and Friday, we're gonna do 7-4, and that's gonna wrap up the chapter for us. All right, so next week we're getting ready for testing, and then we're going to start that third and final project. Don't forget you have data to collect for that third project. Remember what it is? Temperature, how many? 50. How many men, how many women? 25 each. Are you supposed to take people's temperatures? No, not if they consent. No is the answer. All right. All right, and then do on Wednesday, remember. All right, I'll leave this up there for you. Go ahead and get started. I'll do the cell phone lotto.